I want you to imagine a world in which you didn't have switches, the levels of danger which you will be subject to every day, and the unsafe conditions in which you would operate appliances and equipment. So before we even go to using the switches, we need to understand the types of switches which are there and the various categories in which they fall in. After this video, we're going to make a follow-up video whereby we're going to talk about how we can use these switches after having the knowledge of how these switches function and their uses. Here's a list of things which you can expect to learn from this video. So here's the history of where switches began. You can read through it by pausing the video. So essentially, a switch works upon breaking and making a circuit. We know that electrons flow for there to be an electric circuit. So by hindering this flow, that is by breaking or making this flow, which is accomplished by having 2 points of the circuit connecting each other, or 2 points of the circuit being open circuited. That is how a switch functions. So we have types of switches, and these types of switches are determined by the number of poles and the number of throws in which the switch has. So a pole is indicated by the number of circuits that one switch can control, and the throw indicates the number of contacts that the switch has. So here's a single pole, single throw switch. As you can see, we have one contact point here, and we have one circuit indicating that it's a single pole, single throw. Then we have the single pole double throw switch. We have one circuit here, then we have two contacts here, which means at either of the time it's connected here or here. Those are the two contact points and the double throw. Then we have the double pole single throw. We have two circuits here, but we only have one contact point. The two circuits indicating the double pole, then the one contact point indicating the single throw. Then we have the double pole double throw, two circuits, then two contact points, the double throw, then the double pole. Then we have the classification of switches. These are classified as detection switches, manual switches, and setting switches. Manual switches are used to allow workers to make inputs into equipment. So we have the tactile switch or the push to make. This switch, when you press it, it makes the circuit. When you release it, it breaks the circuit. However, there are other variations whereby it works in the converse. When you press it, it breaks. When you release it, it makes the circuit. You can configure it another way around, because this switch already has some points which are already in contact, and when you release it, those points release their contact. Either way it can work. Then you have your rocker switch. Your rocker switch is now a different switch. It's a push to break switch. When you press it, you make the circuit, and when you press it again, you break the circuit. However, we also have this other variation of the rocker switch. This has 3 contact points, which means when you press it, you go to the one setting. When you press it again, you go to another setting. And when you release the setting which you have pressed, so that it stay there, it will stay there until you press again. Then we have the toggle switch. A toggle switch is an example of a single pole double throw switch, because it has one single middle point, then it has 2 contact points indicating the double throw. Then we have the push button. A push button is just a push to make button. However, there are other variations whereby it's a push to break, but the push button switch comes from the sense that you have to press it, and it has a button like this one, hence the push button switch. Then we have setting switches. Setting switches are used to set the position of objects. You have the dip switch and you have the thumb wheel switch. So normally when you look into motor circuit drivers and servo motor controllers, or even stepper motor drivers, they have this type of switches. These type of switches, they are used there to set the direction in which you want the motor to move, or even the steps you want the stepper motor to take. And I've also found these ones in development boards whereby you want to set the pins of a microcontroller, whether they are pulled high or they are pulled low. However, this is too technical, but I just wanted to point out areas in which these types of switches are used. So you have detection switches. These are used to detect the position of objects. We have your miniature detection switch and the basic switch. So essentially this type of switch is just a push to make switch, because when this lever is pressed down, it makes the circuit underneath, and when it's released, it breaks the circuit. This is usually used if you have ever heard about limit switches. When you have an object moving, usually in robotics or in CNC machines, you want to know that you have reached the end of the workpiece, or you have reached the end of the work area. And these switches are used so that the machine knows, like the control circuit knows, that the tool has reached the end, and it does not overlap to go to the other side, and it goes back within the defined range. So when you have a workpiece or a functionality whereby you want something to work within a confined region, these are the types of switches which are used. So essentially this is just a push to make, but it's now engineered so that it functions as a limit switch, because as you can see, this one is a little bit rugged, and as well as this one again, it has a lever so that it captures a wide range of area, whereby if you have an object moving, chances are very slim that it's going to miss this lever switch, unlike the push to make button, which only has a small surface area. We promote areas of the object missing the switch. Then we have semiconductor based transistors. Transistors are based on the semiconductor technology, and they were invented in America at Bell Laboratories by William Shockley in 1947. It's usually a 3-terminal semiconductor device. However, there are other variations of transistors whereby you don't have only 3 terminals, you have more than 3 terminals. So we have the BJT. A BJT is classified into 2 types, the NPN and the PNP, and this mainly comes from the structure in which the semiconductor material is constructed. Like in the NPN, with the N material, the P material, then the N material. That is how it is made. And this is the circuit symbol for the NPN. Then underneath we have the PNP, as indicated. We have the P material, N material, then the P material. Then this is the circuit symbol for the PNP transistor. So these types of switches are current controlled, unlike the other ones which we were talking about earlier. Those are mechanically controlled. So these are current controlled. You feed the current into the base of the NPN transistor, then you feed a current into the base of the NPN transistor. A current is going to flow from the collector to the emitter, making the connection between the collector and the emitter. On the PNP transistor, you feed a negative current into the base of the transistor, and when you feed this negative current is going to flow from the emitter to the collector, and some of it is going to flow through the base to your control circuitry. So these are current activated devices, as we were mentioning earlier. You feed the issue of feeding currents, and they have low switching frequency, and they also dissipate heat. However, there are other configurations whereby you can minimize some of these features, like the dissipation of heat and higher current handling capacity, like using the Darlington pair or even the Ziegler pair. Then we have the metal oxide semiconductor field effect transistor. These were an advancement from the BJTs because they actually had better improvements and better features as compared to the BJT. Again, we have 2 types, the N channel and the P channel. On the N channel, current flows from the drain to the source. On the P channel, current flows from the source to the drain. Then there must be a negative voltage between the gate and the source for the P channel to turn on, and 0 volts between the gate and the source for it to turn off. And on the N channel, there must be a positive voltage from the gate to the source, and for it to turn on, then 0 volts from the gate to the source for it to turn off. However, these values for the VGS, the gate to source voltages for both of the transistors, is indicated in the datasheet of the particular MOSFET which will be in question, because there are various MOSFETs out there and there are various manufacturers out there, so they were going to indicate their specifications in the datasheet. So you have to read the datasheet for you to understand how to use the MOSFET or the P channel or the N channel MOSFET. Then like I was saying earlier, these are better features as compared to the BJT. They have higher current handling capacity, they have very high switching speeds, and this is a voltage controlled device. Like I was saying earlier, there must be a positive voltage between the gate and the source for you to turn on. It's not based on the current but based on voltage. Again, here negative voltage. Then now let's talk about applications. Which type of switch to use when you're turning on an AC light. So when you're turning on an AC light, you can just use a rocker switch, the push to break switch, which we talked about earlier. So this is a rocker switch, and the rocker switch is the best one to use in this application, because When you press it, it makes the circuit, thereby you have your light on. When you press it again, you turn off the light. And these one are the best as compared to semiconductor devices because they incorporate a conductor inside, and this conductor is purely conductive. It's not a semiconductor. So when it's a purely conductive material, it's going to dissipate low energy in terms of current losses, unlike a semiconductor will always dissipate more energy as compared to a pure conductor. That is why we are using this one. Dimming on a DC light. So when it comes to dimming a light, this is now a complicated task because there's issues with controlling the levels of voltages or even controlling the current. So using the mechanical switches is not possible with this application. So in this application, you may actually want to use a MOSFET, given the features which we have talked about earlier. Now for low power consumption, like I was saying earlier, you just use a mechanical switch because it incorporates a pure conductor. It does not have a semiconductor inside, so it will be the best one for low power consumption. Then let's talk about problems with switches. Okay, so we have arcing. Arcing usually happens when A is ionized through the presence of a high voltage, and current is able to flow between two parts of the circuit because of this ionized A, and we have what is called plasma. Okay, we have lightning. Lightning is another natural example of arcing because we're saying we have the clouds and the ground, and in between we do not have a pure conductor, but the potential difference between the ground and the clouds has risen to a level whereby the air has been ionized and air is now conductive, thereby the current is going to flow from the clouds to the ground or vice versa. Thank you guys for watching. Please do like, comment, share and subscribe, or even dislike